Gucci gang, Gucci gang, Gucci gang. Welcome back, everybody. Is it Gucci gang or Gucci Mang?
Gang.
Is Gucci Mang also a thing? Like man, Mang? Okay, I thought so. Like, I'm hip. All right, cool. All right, what the function? So let me rephrase that so it's not caveman. What's a function? Ooh, here we go. What's a function? 60 seconds, discuss. You gave me a simile. I heard you say a simile. It's like a machine, man. What's it do?
Oh, a machine where you put something in, you plug something in, and spit something out.
It's like kind of like a machine. It's a mathematical machine where you put something in, an input, and it does some magic behind the scenes, and you get something out of it, an output. Okay, at its most basic, that is true. Like, I agree with that completely. I think of functions as being machines. I really do. Now, specifically, we're going to blast through a bunch of, if that wasn't you, that was my bad. I know I heard it over here. I thought it was you. We're going to sneak through a couple definitions really, really fast because I really want to get to the fun here. All right. So, a little bit of background. So whether we call this background, it's kind of like us just getting into thinking about it. What I'm really hoping to do with this first section is I want us to build a little bit of intuition mathematically. You guys have a good idea of what things are and aren't functions, maybe. Can you imagine a graph that's not a function?
Yeah.
What did you imagine? A whole bunch of dots. I think depending on where those dots are, they could be a function. If a circle is a good example of a non-function. Now, there's something that you have to be very mindful of if you're thinking about the graph. What sort of line test? If I put in 5, how many things should it spit out? Like, if I plug in x equals 5, should it spit out y equals 2 and 7 and 9 and 5? No. For every input, it should spit out how many outputs? 1. If it does any more than that, it's not a function. Now, the way that we start making sense of this, a little bit of background intuition. We are going to really quickly define a relation. So I know that this isn't a function yet, but a relation is like the basis for where we build functions from. Okay, in mathematics, when we talk about a relation, super duper easy. It's just a set or a collection, but I'm going to use the word set. A set of ordered, and I'm going to say the word pairs, but I do want to, you don't have to write it down, but I do want to just make sure that we're aware of the existence of higher math than what we're doing right now. For our purposes, a function is a set of ordered pairs. When you see this in a higher level course, you might not see ordered pairs, you might see ordered tuples. Okay, like it sounds dumb, tuple, you've probably never heard that word, but you think of two things together as a pair, right? That's in 2 dimension. Do we live in 2 dimensions? So on paper, xy is our point. What's a point look like in 3 dimensions? XYZ. You just add another one. So that's a 3-ordered triple, right? There's a pole part of it. Anybody think about 4 dimensions? I certainly can't. I can think in 3 dimensions. 4 dimensions, nope. Can we do math in 4 dimensions? Yeah, instead of XYZ, it's XYZW. With that, could we do math in 5 and 6 and 7 dimensions? So I don't really care if we're talking in 2 dimensions in here in this class, 3 dimensions in a calc like 2 or 3 class, or 10 dimensions in physics when you're doing your master's or doctorate. It doesn't matter. If there's a set of points, ordered tuples, whether it's 2 or 5 coordinates, doesn't matter. You get a relation. Now, in this, for our purposes, we only work in 2 dimensions, which is nice. If you take only the x values to some big collection of ordered pairs, you get something special. Starts with the domain. Okay, I'm going to be really concise with the way we write these. We can expand if needed. The domain of a relation, very specifically, the set of what goes in here, x values. I'm going to say vowels for values. These curly brackets, what do they mean? Set. So not in the set of, although I like where your head's at. Anytime you see these curly brackets, it just means a set. I don't know why I put a comma. All right, if we take all the x values from some big collection of a bunch of ordered pairs, we call it the domain. What do we call the range? What do we call the y values? Hey, you guys are killing it. The range, the set of the y values. Now, we are using x and y because that's what we normally kind of default to. Could I put a in and it spits b out, though? Like, instead of using f of x equals y, could I use f of a equals b? Same thing, I'm just changing the letter. So instead of saying x values and y values, input, output. Same language, but it clears up all the possibilities. I'm not going to write it. We will use x and y primarily, but inputs and outputs are the same things. What goes into your function? Input, and it's the normally x's. The output is normally what? The y value that it gives you. Okay. Now, everybody okay without doing a bunch of crazy stuff with these? So here we go. We have a relation, a set of ordered pairs. Imagine any function. I lied. Let's think of an easy function. Let's think of y equals x. There's, like, if we draw it, we're drawing infinitely many points, yeah? Can you list those points? Now, we can't list all of them because we don't have enough time. Is the point 1, 1 on it? Yeah, 1, comma 1. Is 1.01 and 1.01 also on it? And 1.001 and 1.0001. Like, all those points are there, right? We can't write all infinity of them, but there is something special. We can refine this relation just a little tiny bit to define for ourselves a function.
Mr. Holloway,
Yo,
is there a word for z values? Is it like domain and range of x and y? Is there a word for
ooh, I'm sure there is. I don't know it off the top of my head, but I have some time at lunch. It's been a long time since like, that's a pretty specific thing to Calc 3, and I haven't taken Calc 3 in a long time. Yeah.
I like that.
It's Calc 2 is the hardest. Anyway, function is simply a relation which has a 1-to-1 mapping from each x, or I'm going to say from x to y. A 1-to-1 mapping. All that means is for every 1x that I ever plug in, it spits out how many y's? 1y. 1-to-1. Instead of x and y, more common language that we might use, what do we call the collection of all the x's of a function? All of the x values. The domain. So if we want to be more specific, a relation which has a 1-to-1 mapping from domain to where? Range. They are interchangeable. X to y, domain to range, A to B. I think your book uses because they use different letters just to generalize it. I'm good with this. Now, we are going to see one single example like this. I'm going to give you one on the homework, and then here's the honest truth. We'll never see it again. Okay, like it's here. We can think about it. I'm going to give us a simple example, and I want to know for the following. I want you to identify the domain, range, and then all I want to know is it a function? Which I'm going to caveman right. Is it func? Bow. All right. Little bass action for those of you that might have caught that. All right. I'm going to give us a nice, lovely relation. What's your favorite letter, Addison?
A.
That's what I was guessing you would go with. All right, so we're going to make a set of ordered pairs called A. Capital letters are traditionally used for sets of numbers. But here we go. I want the following. I want 1, 2. I want 2, 4. And I want 3, 4. And 3, 5. Those are my 4 ordered pairs. I hate having commas with commas because it looks awful. How many elements or members do we have in this set A? 4 of them. If you were tempted to say 8, it's because you were looking at both, but each element, each part of this set is just that ordered pair. Okay, for this, right off the bat, we can't tell if it's a function or not. For shorthanding, here's what I will default to. For domain, we're talking about the domain of, what's the name of the set? Or this relation, we can say? A. I want to identify the domain of A and the range of A. And then we'll decide if it's a function or not. Without me working this problem with you, do you know what I'm asking you to do? Okay, if you don't, talk with your neighbors, talk with me. I'm going to give you about 60 seconds. I don't think you'll need that much time. Tell me the domain of this, the range of this, and then determine with your neighbors if it's a function, and we'll come back together here briefly. If you're watching this video, everybody's here. Okay, never mind. Check it out. Domain is what?
1, 2, 3.
Okay, could I write 1, 2, 3, 3?
Yeah.
Yeah, I don't need to because that same element is listed, but there is a really important observation I want to make out of this. I'm going to write 3, 3 this time. If you just have 1, 2, 3, you are also correct. Range. 2, 4, 4, 5. All right. Now, as we're looking at this, I agree with you. 3 things in the domain, 3 things in the range. Why is this not a function? 2 clappers.
Because there's 2 4s in the range.
So that part, so I'm gonna argue against you. You say because there's 2 4s. This is a function. There it's 4 and there it's 4. I don't have a problem with that. If we have a repeat in the x's that spit out different y's, we have a 1-to-1 mapping, right? This value of 3 spits out 2 different values, though. That's not a function. This is what breaks it. So I'm just going to answer not a function, not funky. And very specifically, I'm going to make a little warning here. Repeated domain is all I need to think about. Now, one little word of caution. I don't like to give like trick problems. I don't think that's a good way to do stuff because I never want to have it like, aha, I got you moment. If this had repeated, it doesn't automatically mean that we're broken. If I had 3, 4, and 3, 4, would it break that rule? No, because 3 just spit out 4. Like, I'm okay with that. It would be dumb to do it, which is why I think it would be a trick question. But if it repeats and it's the same ordered pair, you're good. It shouldn't repeat, because that's not a good way to write the set, but it could. Okay, doable. All right. So, if I want to know if something is a function, normally we don't write functions like this. Do you guys remember ever talking about the word mapping?
Yeah.
Okay, does it make you think of a picture?
I think that is circle.
Okay, so you will see this later. You don't have to draw this yet. But if you think of this, where I have 1, it maps to
Yeah.
2, and then what our issue was when it does something like this, it breaks it. Remember this from last year, I assume?
No.
Oh.
2 years ago.
In geometry?
No, it was 8th grade.
That is awesome that you remember something from Miss Jarvis. I'm going to tell her that here in just a few minutes. All right, but let's look at it. We don't normally get our functions like this. Normally get them in the form of an equation, right? Now, if I give you f of x equals, it is a function. Like I'm already telling you just by the way I write it. But we could use y equals instead, right? So here's my question. If I want to look at an equation and determine if it's a function, how could we do that? So we're just going to go, I don't know, what color's a function in your brain? I'm not using yellow. Green. Because we all have NV for functions. All right. Totally derailed myself there. Testing for functions. All right. I'm going to just propose 2 words that are synonyms, I think, and tell me if one of them is scarier than the other if you see it. If I say analytically compared to algebraically, does either sound scarier?
No.
Which one sounds scarier to you? Analytically? They're the same. We do stuff analytically, it just means we're doing the algebra. We're doing it algebraically. They're the same word. I will use both. Algebraically doesn't scare you, it just means we're doing it with algebra. Cool. So, here we go. Testing for functions. The question that we're answering, I don't think I need to write it, is if you give me an equation, how do I check if it's a function? Without graphing it, hopefully. So, let's knock it out. Analytically. Analytic test. All right. Love it. Here we go. An equation. Here we go. An equation. You guys remember my shorthand for equation? EQN. N? Weird. An equation is a function. And can we just assume that we're going to work a function y in terms of x? We'll clean up that language. Can we just use x and y by default? An equation is a function if we can solve uniquely for y. Okay, in the slim chance that we have something other than y equals, y is the independent or the dependent variable? So you could say dependent here. I typically won't ever use different number than y for that. I will use a bunch of Greek letters in place of x, just as we get into stuff. Okay, we need to solve it uniquely. Okay, we're not thinking about the graphs at all. We're going to do another example, and I just want to know algebraically, without having to graph it and do all that stuff, is this a function? So example, function. And we're going to justify as well, but that'll always be part of it. All right, I have something I want you guys to solve for me. For what? We solve it for dependent. All right, that's, yeah, I probably could have asked that better. I think we're good. Here we go. This is on you guys, okay? You're going to do this one without me doing anything. First, you're going to talk it out. Solve this uniquely for y, or don't if you can't. Here we go. 2x squared plus y plus 1. 2x squared plus y plus 1 equals 0. I'm going to give you guys a little bit of time. See if you can solve this uniquely for y. I'll give you like 20 seconds realistically, but pause. So looking at this, I will. Can we solve this for y?
Yes.
Can I do it in one line? Can I subtract 1 and something else? So y equals, and I'm going to rearrange it, negative 2x squared minus 1. Cool. Is that a function? Yes. Now, you may struggle to tell for sure. I'm going to say, yep. Okay. When we talk about solving it uniquely, it can be hard to envision what that actually looks like. It won't be hard in about 30 seconds. We're going to do one more together. And I'm going to just call on random people to help me with the next step of the algebra. Cool. All right. So I'm feeling good, feeling fine. Let's see. I want x plus y squared minus 6 equals 0. All right. There is no rhyme or reason other than whatever the calculator gods decide today. Number 7 is Dolan. I need some help. One step. First thing we want to do to solve for y.
Subtract x on both sides.
All right.
And then add 6 on both sides.
Slow down there, partner. All right. There's my x. Are we cool with that?
Yes.
All right. Dolan also gave me the next step, which I think we can probably all agree on. I'm going to add 6 to each side. Everybody cool with that?
Yes.
Y squared equals negative x plus 6. All right, here's the hardest question out of all this. I'm trying to solve for y, but I have y squared. What do you want to do, Wisha? How do I undo a square? I'm going to take the square root. I'll do the left side. It's y. What's the right side? Okay, here's my big question. Why are we wrong? Oh my goodness. Positive or negative. Okay. At this point, if I said use one of these, because there's 2 answers here, right? Is that unique? We did not. Like, this isn't unique. There's 2 of them. If I plug in a 1 and it's positive, I'm not going to do the math, but it's positive root 5. If I plug in a 1 and I use the negative part of it, the same x now spits out negative root 5. One x value spit out 2 different things. Is that allowed?
No.
Not if you want to be a function.
That's how you know if it's a function.
This is not unique. This is what tells us that. Not unique. Now, one could argue that an exclamation point would work for unique here, but I'm not going to confuse it. Not unique, therefore, or implies, not funky. Okay. Doable?
Yes.
We are so close to finishing this section. Here's the deal. I'm not going to give you homework tonight, but we're going to go for 5 more minutes, obviously. We're going to leave ourselves at a spot where tomorrow we'll jump right in with a problem and then likely do one more on top of it because you guys will think it's harder than it is. We'll have a lot of time in class tomorrow for quick homework. We'll work through it, and the rest of the class we'll make a note card together.
Yep.
Remember, I'm going to let us do note cards for the first quarter probably, and then we'll start easing out. We'll take away a little at a time. Okay. We're also, do you guys like finals?
No.
Okay, so me neither. So we won't do finals. We'll do like midterms and stuff. We'll just do cumulative tests like regularly.
Yeah.
Cool. Like,
Yeah.
yep. Not what I was expecting you to say. I really just told you you're going to get 4 finals, and everybody said, "Oh, thank goodness." But okay, we'll work on it. Like, yeah. I was not expecting that reaction. All right. Cool. Let's talk about notation. It is a good thing for your learning, I promise. Function notation. All right. Language-wise, we're going to clean stuff up. What do we name functions? What's the natural standard? So f is the name of the function, and the of x part just tells us we have a function f whose variable is x, or a function f that we're going to write in terms of x is the other language. So when you see in terms of something, it just says what's the variable. Okay, when we're looking this, we're just going to dig right in and try to go through kind of quick. We name them for reference. So if I have one function as f, the next one g commonly, but does it really matter? No, not at all. I would not use something like super misleading like x of x, although it will happen. There are situations. We're going to try to avoid it. Okay, so let's say that we have f and then of x equals, and I don't really know, we'll just make an easy one, x squared minus 4. How do we read this? Just this. F of x. Okay, very specifically, if you can remember this, you don't have to write it. This is a function called f, or named f, in terms of, what's the variable we used? X. Okay, this is literally what it means. The function is f. When we say of x, we're just talking about the variable. Okay, doable? Okay, so quick, easy thing, I think we'll be all right. If I wanted to evaluate, and e.g. is less than a hard, like regular example, if I wanted f of 3, how would you do this? Like, where, I heard plug it in right off the bat. Plug it in where? To what? For anywhere there's an x, I'm now going to replace it with a 3. Anytime you're doing this, you may not always need it, like legitimately, but it's a good practice to get in the habit of. I should put something around this 3 when I put it inside. Parentheses. So now, I'll come back and I'll do it in red. If I'm trying to find f of 3, anywhere there's an x, I'm going to put a 3 inside of parentheses. What does this come out to, just out of curiosity? 9 minus 4? 5. Okay. Anybody think they might have been guilty of not using the parentheses? Do you remember a time where it's kind of burned you on your math? Can you tell me that time?
Like a specific time?
I mean, it doesn't have to be like,
Like with negatives?
with negatives is where it's going to happen. F of negative 2. If we don't follow this convention of adding these parentheses, even when they're not necessary, if you don't think about it and you don't do it now, you probably won't do it when they do really need them. If I want to find f of negative 2, what gets plugged in? Negative 2. Now, if you are on a calculator or on your page, this is a really common mistake for people to make. And it doesn't really look like anything bad has happened. Does it change the outcome? PEMDAS says that if this is what's written, what's 2 squared? 4, and then we multiply because x1 has happened first. This is negative 4 minus 4. It'd be negative 8. We are wrong if we do that. When we add these parentheses, does it change everything? What's negative 2 squared? 4 minus 4? We see it 0 in this situation. It matters. Okay. 60 seconds. We're going to write the next little subtopic, but we'll start tomorrow. Okay. We're going to talk about domain of a function at the start of class tomorrow. And then we're going to see this lovely thing that really legitimately is the first little taste of calculus that you'll get. You won't even feel like calculus, I promise. Cool. You can start packing up.